Most data governance programs fail in the same place. Not at strategy. The strategy is usually fine. Not at tooling. Most teams have a catalog. They fail at stewardship. At the part where a human being has to look at a data set, understand what it contains, classify it, document, tag it, and keep all of that accurate as the data changes underneath them. Multiply that by 10,000 tables, 100 pipelines, and a team of 3 stewards, and you have a bottleneck that no amount of hiring will solve. That bottleneck is why a new term keeps showing up in governance conversations, the AI steward, sometimes called the agentic data steward. And right now, there's genuine confusion about what it means. Is it just automated tagging with a fancier name? Is it a replacement for human stewards? Is it something that actually works? Or is it another governance concept that sounds good in a slide deck and collapses in practice? This guide gives you a clear, defensible definition, and more importantly, shows you what an AI steward actually does, how human stewards work alongside it, and what has to be true for any of this to work in the real world. We've watched governance teams hit the same wall over and over. The aspiration is comprehensive stewardship. The reality is triage. The stewards who get this right aren't the ones who work harder. They're the ones who figure out which work needs a human and which doesn't. That distinction is exactly what the AI steward model is built around, and understanding it clearly changes how we think about our own governance programs. An AI steward is an AI agent that performs the routine, pattern-recognizable work of data stewardship, classification, documentation, tagging, ownership assignment, policy enforcement, autonomously, within guardrails defined by human stewards. The human steward doesn't disappear. The human steward becomes the person who sets the rules the AI steward follows, reviews its work, and handles the exceptions it escalates and refines its behavior over time. That split is the core of the model, not replacement, redistribution. The AI handles the volume, the human handles the judgment. And here's why the distinction matters right now. The term AI steward is actively debated. Some practitioners resist it. They feel it anthropomorphizes what is essentially automation and diminishes the human role. Others find it useful shorthand for a genuinely new operational pattern. Both sides have reasonable points. What matters more than the label is the underlying model. An AI agent then can act on data governance tasks independently within defined boundaries and a human steward who operates at the policy and oversight layer. Whether we call that an AI steward, an agentic data steward, or AI augmented stewardship, the operational model is the same. For this guide, we use AI steward as the working term, but the concept is what matters, not the name. Understanding why AI stewards are emerging requires looking at the math that governance teams live in every day. A mid-sized data organization might have 20,000 tables across its warehouse, lake, and streaming infrastructure. Those tables change. New columns appear, schemas shift, pipelines get refactored. Every one of those assets ideally needs documentation, classification, ownership, and ongoing maintenance of that metadata as the underlying data evolves. Now look at the stewardship capacity. Most governance teams we hear about have somewhere between 2 and maybe even 10 dedicated stewards. Some organizations try federated models, asking domain experts to steward their own data, but those domain experts also have day jobs. Stewardship becomes the thing they do when nothing else is urgent, which means it rarely gets done. The result is predictable. Most data assets in most organizations have stale, incomplete, or non-existent metadata. The catalog becomes a graveyard of last quarter's documentation. And when metadata is unreliable, nobody trusts the catalog, which means nobody uses the catalog, which means the investment in governance tooling delivers a fraction of its potential value. This isn't a people problem, though. It's a scale problem. And scale problems don't yield to effort. They yield to a different operational model. The reason that model is feasible now, specifically in 2024 and 2025, is the convergence of two things. First, LLMs have reached a level of reasoning capability where they can do more than pattern match. They can interpret context, handle ambiguity, and make decisions that would have required rigid, hard coded rules before. Second, active metadata platforms have matured to a point where an AI agent has something meaningful to reason over: connected lineage, usage signals, schema change histories, quality metrics, existing tags, and classifications. Without that rich metadata substrate, an AI agent is guessing. With it, the agent can make informed decisions, the same way a senior steward uses context, not just column names, to classify data correctly. Building on that foundation, we need to get precise about what makes an AI steward agentic, because this is where most of the confusion lives. The spectrum looks like this. There is rule-based automation, and that's the simplest level. If a column contains SSN, tag it with PII. If a table hasn't been queried in 90 days, flag it as stale. These rules are fast and predictable, but they're brittle. They break the moment naming conventions vary, which is actually consistently. They can't handle context. The word address means something fundamentally different in a shipping table versus an IP logging table. Rule-based systems don't know that. The next level is AI-assisted stewardship. An AI model examines a dataset and suggests a classification. This column likely contains email address, confidence 87%. A human steward reviews the suggestion and approves or rejects it. This is meaningfully better than rules because the AI can reason over content, not just names. But the bottleneck hasn't moved. Every suggestion still requires a human to review it. If the AI generates 1,000 suggestions a day, a human still has to process 1,000 decisions. The queue gets shorter, but it doesn't disappear. Then we have agentic stewardship, and it's qualitatively different. An agentic AI steward doesn't just suggest, it acts. And not in a single step, it perceives the state of the data asset, reasons about what governance actions are needed based on the organization's policies, and executes a series of actions, checking its own work against those policies. It only escalates the cases where the confidence is below a defined threshold or the situation falls outside its authorized scope. Here's what that looks like more concretely. A data engineer deploys a new table to the production warehouse on Tuesday afternoon. In a traditional model, that table sits undocumented until a steward actually notices it, which could take days, weeks, or never even happen. With agentic stewardship, that flips completely. There's 8 steps, 7 handled autonomously, 1 escalated. The human steward's morning starts not with a queue of thousands of assets to review, but with a single targeted question. What is user ref in this context? That's a question worth a human's time. The other 7 actions were not. And here is what agentic doesn't mean. It does not mean unsupervised. It does not mean the AI steward has unlimited authority. It does not mean the human steward is optional. Every action the agent takes is logged, attributable, and auditable. The human steward can review any action, override it, and feed that correction back into the agent's future behavior. The guardrails are not a safety net. They're the architecture. Without them, this model does not function. We'll come back to that. Now that we understand what agentic means structurally, we can look at what it feels like operationally. The daily rhythm of a governance team where an AI steward runs alongside human stewards. The AI steward has been working overnight, not because someone scheduled it, because it operates continuously. Data assets change and the AI steward responds. A schema modification happened at 2 a.m. when a data engineer renamed a column from cust.id to customer identifier in an upstream table. In an unmonitored environment, that rename breaks downstream metadata silently. Tags become detached, descriptions reference a column that no longer exists, and lineage connections go stale. The data catalog drifts from reality, and nobody notices until an analyst finds conflicting information 3 weeks later. Now, the AI steward detected the schema change, traced the lineage downstream to every affected asset, updated the propagated metadata, reevaluated classifications against the new schema, and generated a notification noting what changed and what it did in response. The human steward reviews the notification over coffee. Everything checks out. Total human time, 45 seconds. Now consider a second scenario from that morning. The compliance team has a quarterly audit approaching. In a financial services firm, they need to demonstrate that all customer data assets are classified and access controlled. In the traditional model, this triggers a 2-week scramble. Stewards manually auditing hundreds of tables, checking that classifications are current, verifying that access policies are applied. It's stressful, expensive, and reactive. With an AI steward running continuously, the classifications are already in place and current. The audit trail shows when each classification was made, what evidence the agent used, whether it was human verified or agent applied, and what the confidence score was. The compliance team generates a report showing coverage percentages, confidence distributions, and exception handling records. The quarterly audit goes from a 2-week scramble to a 2-hour review. The third moment from this morning is smaller but equally telling. The human steward gets an escalation on that ambiguous user ref column from the new table. The agent's note says, column contains alphanumeric identifiers. Content pattern is consistent with both internal user IDs and external customer reference numbers. Lineage suggests that this table is derived from the CRM pipeline, which typically contains customer-facing data. Confidence for PII classification, 73%. Below the 90% autonomous action threshold, routing for human review. The human steward actually knows this domain. They recognize that useRef in a CRM-derived table is indeed a customer reference number. They classified it as PII, and that correction feeds back into the agent's model. The next time it encounters a similar pattern in a CRM-delivered context, its confidence is higher. This is the compounding loop. The agent gets better as it has more metadata to work with. It generates metadata as it operates, and human corrections sharpen the accuracy over time. The catalog goes from sparse to rich, not through a one-time migration effort, but through continuous, iterative stewardship. Everything we've walked through so far implies something significant. The human steward's job description changes, not disappears, changes. In the traditional model, a data steward's week is dominated by manual metadata maintenance, writing descriptions, applying tags, checking classifications, updating ownership records. Industry estimates suggest this repetitive work consumes 70 to 80% of a steward's time. 70 to 80%. The remaining 20 to 30%, that is the work that actually requires a human and gets squeezed into whatever time is left. When an AI steward handles this routine 80%, the human steward's time inverts. The judgment-based work becomes the primary job, not the residual. That means the skills that matter shift too. The human steward of the future needs to be a policy designer, someone who can translate organizational governance requirements into clear, machine-interpretable guardrails. Auto-classify PII in production databases, but not in sandbox environments. Auto-assign ownership based on lineage, but require human approval for cross-domain ownership transfers. These are governance design decisions that require understanding both the organization's risk posture and the AI agent's capabilities. The human steward also needs to be an exception handler, someone who can resolve the cases the AI steward can't. These are often the most interesting and consequential governance decisions. Is this data set subject to the GDPR if it contains hyphenated data? Should this experimental ML feature table be governed to the same standard as production analytics tables? These questions require institutional knowledge, ethical reasoning, and cross-team negotiation, work that is genuinely human. And the human steward needs to be a trust broker. Someone who builds confidence in the governance program across the organization. When a business analyst asks, "Can I trust this data set?" the answer now involves explaining how the AI steward classified it, what confidence level it achieved, and what human verification has occurred. The steward's credibility transfers to the system's credibility. That transfer only works if the steward actually understands and can explain the agent's reasoning. The final piece is practical: how organizations are actually adopting this model and where they actually stumble. The pattern that works looks like this. Start with one domain: marketing data, finance reporting tables, a specific product's pipeline outputs. Define clear initial policies: what the AI steward should classify autonomously, what tags it should propagate, what ownership rules it should follow. Set confidence thresholds. A common starting point is to allow autonomous action above 90% confidence and escalate everything below that. Run for 30 days with high human oversight. The stewards review a significant sample of the agent's actions, not because they have to, but because this is a trust building phase. They're learning what the agent gets right, where it struggles, and what policy gaps exist. After 30 days, the team reviews. In a well-run pilot, we typically see the agent handling the vast majority of routine stewardship actions correctly, with human corrections needed on a small percentage, often around 5 to 10% initially. Those corrections are fed back in. Policies are refined, confidence thresholds are adjusted, and the team expands to a second domain. Now, the pitfalls mirror the patterns. Teams that try to apply AI stewardship across their entire data estate on day one get overwhelmed by expectations and lose confidence in the model. Teams that set confidence thresholds too low, allowing the agent to act autonomously at 60% confidence, end up with misclassifications that erode trust faster than no classification at all. And teams that deploy AI stewardship without investing in their human stewards' new skills discover that the AI agent is only as good as the policies it operates under, and weak policies produce weak governance regardless of how sophisticated the agent is. The organizations getting this right share a single common trait: they treat AI stewardship as a governance architecture decision, not a feature toggle. They think carefully about what the agent should do, what it shouldn't do, and how the feedback loop between human and AI improves the system over time. We've covered what an AI steward actually is, what makes it agentic rather than just automated, how the human steward's role evolves alongside it, and what realistic adoption looks like. The core idea is redistribution, not replacement. The AI handles the volume, the human handles the judgment, and the feedback loop between them is what makes governance actually scale. But knowing the model is one thing. The next question is, how do you evaluate whether your organization is actually ready to adopt it? And what needs to be true about your metadata foundation before an AI steward can operate effectively? That's exactly what we get into next.